Hi, for this video, we are given a quiz and a hypothetical student's solutions, and we're asked to look over their answers and determine whether the student's solutions are correct or incorrect, and if they are incorrect, then we need to correct them, provide a correct step-by-step solution. So in the first problem, we are given that tangent theta is 3/4 and cosine theta is greater than 0, and we're asked to find sine theta and cosine theta. And in the student's solution, their step 1 is to note that there's a trig identity, tangent theta equals sine theta over cosine theta, and then they incorrectly deduce that sine theta is 3 and cosine theta is 4. That's only true when you are working in a unit circle. Otherwise, when the radius is not 1, you need to deploy another tactic. So we're going to go ahead and solve this using the right triangle trig definitions. Okay, so that's the incorrect part. So first, let's draw our angle. Tangent theta equals 3/4. So tangent theta is positive. We know, let's see, all students take calculus. We know that tangent theta is going to be positive in quadrants 1 and 3. We're also given that cosine theta is greater than 0, and cosine theta is greater than 0 in quadrants 1 and 4. Since both of these conditions are true, we know that the angle is in quadrant 1. So let's draw an angle in quadrant 1. We're going to label it theta. Drop a perpendicular, and because tangent theta is 3/4 and tangent is opposite over adjacent, we can label our sides as 3/4. We're going to need to calculate that length of the hypotenuse. We could use the Pythagorean formula, but you also might note that this is a 3, 4, 5 triangle, so we can label the hypotenuse as 5. Using the right triangle trig definitions, we know that sine of theta is going to be equal to opposite over hypotenuse, and opposite is 3 and the hypotenuse is 5, and we also know that cosine theta is equal to adjacent over hypotenuse, and we know adjacent is 4 and the hypotenuse is 5. So that's problem 1. Problem 2 is correct. Good job, hypothetical student. Okay, problem 3 is incorrect. Let's look at that. Let theta be an angle in quadrant 4. So we can actually start by drawing that. Quadrant 4. So we're going to draw this angle, call it theta. And just like we did before, we're going to drop this perpendicular to the x-axis. And we also know that the cosine of theta is 1/4. So we could go ahead and label our sides just like we did in the first problem. The cosine is adjacent over hypotenuse, so we have adjacent is 1 and hypotenuse is 4. We will need the length of that third side as well. So let's go ahead and calculate that. So the third side, which is the opposite side, let's call it y. We know that y squared is equal to 4 squared minus 1 squared. That's the Pythagorean formula. We can calculate 4 squared minus 1 squared is going to be 15. So therefore, y is equal to either plus or minus the square root of 15. Whether we take the plus or the minus root, or the positive or the negative root, depends on the value of y. Well, we know that y is going to be negative, so we're going to take the negative square root of 15. From there, we can calculate the sine of theta, which is going to be opposite over hypotenuse, and the opposite is negative square root of 15, and the hypotenuse is 4. If we look, go back and look at the student solution, they do correctly state the Pythagorean identity. And then they go ahead and use that Pythagorean identity with the fact that the cosine of theta is 1/4. So they substitute in the 1/4, and they're solving for sine. So they end up with sine theta equals the square root of 15 over 16. But here they neglected to include either the positive or the negative root, and then choose the negative root. So that's where they made their error.